this is the question on LZ, okay, Lempel-Ziv itself. Perform the coding, encoding and the decoding, all right, of the following data. So the data is A, B, A. Yes, so you will have alphabets, this thing, A, B, A, B, B, A, B, A, triple B, okay. B, A, B, 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 then A, B, B, A. Okay, so our approach will be because since we are familiar with the dealing in binary or any other format so far, right? So our first approach will be converting. Maybe you just have to make an assumption like let A is 1 and maybe you can write, okay, B is equal to 0. You make an assumption like this. So convert that your data into, right, according to your whatever assumption, like this. Say, for example, this will be 1, 1, 0, 1, B0, so 0, 0, 0, and so on. Okay, you have a data. Now proceed as per our previous technique. Okay, so you will do that. At the end, you get a code, right? So let's assume that I get a code like 101100, whatever, right? Convert it back according to the same convention, put it back, right? That's what will be your coded signal. All right, so 1 will be A, so this is AB, AA, whatever, right? BB dot dot dot. So like that you get an answer that will be your coded signal. Right. So if you can solve the problem directly with this AB itself, definitely no issue, right? But since we are familiar with the numbers rather than the letters, right? So this is the method to be followed. Okay. Yeah. Solve this. And if you have any doubt, let me know. I'll help you. All right. So fine. So there is an upgradation to this technique. That's what we are going to look today. All right, so and that method is called as Lempel-Ziv LZW. So right, what's W? You know, no, it's Welsh, WELSH. Okay, algorithm. This is LZW. Okay, so in this technique, they are trying to further compress, okay, whatever is existing in Lempel-Ziv. They try to further do compression. There is a slightly different mode of doing the encoding, right? We still do the dictionary part. There is the dictionary part will be there, okay? And in addition to the dictionary part, we slightly use a different technique of encoding. Like I take up one, so grouping is made in a slightly different portion, slightly different way. That's the first thing. So in that case, we try to overlap, right, the groups. Like I have A, let's say A, B, is my case. So I do A, right? Then overlap with AB. So that's how you get a next group, right? So what is already existing, with that you try to make a next group. Okay, so next will be BB. Then you have BA. You see that every time you overlap, that's a new thing over here. So because of that, the fundamental difference is that in case of the simple LZ algorithm, even if there is a single bit called A, you had to code that single it can be bit, single number, single digit, or single letter, whatever. You used to give a notation for that, like 001. So A used to get coded by 3 bits maybe, right? In case of LZW, that condition is avoided. You never encode a single letter, right? So I have single letter A, single letter B, single letter C. No, they are not going to be coded, right? No coding. You save that much space you save. That's why we say it is more compressive algorithm. Okay, so this is one of the highest compression ratio, which provides the highest compression ratio based on the dictionary. So what we are studying here is a dictionary based encoding algorithm or dictionary based compression. Okay, among the dictionary based compression or encoding schemes, this LZW provides you the highest compression ratio. That's why it is considered as one of the best suitable compression technique. Okay, uh, uh, under the particular category of dictionary based encoding schemes. All right. Okay, so as usual, first I'll deal with the theory question, like what if they ask a question related to explain or yeah, what is this algorithm? So first we'll deal with that. We'll also look at the decoding part of that in 4 or 5 steps. Okay, we have 4 or 5 steps in this case, right? First encoding, 4 or 5 steps, then decoding, 4 or 5 steps, then we'll start solving problems. All right. Okay, so fine. So we'll start with the encoding. So here we'll discuss about the. So if a theory question comes, explain the encoding of that, right? So we will write step by step. So first step is that we start with the initialization of the dictionary. Initialize the dictionary to contain each entry. It can be an entry or byte. So this is a technical term. When we actually write, it's slightly different. We take either maybe a bit or a number or a character, or it's like that. Okay, each entry or a byte, because again, this is a technical term we see in the textbooks, because normally if a computer stores the data in the form of a byte, each byte can also be considered. Okay, a group of 8 bits can be considered as one entry. All right, so that's why this term comes. But anyway, don't worry about the word byte. Now when we solve the problem, we will not look into byte. Okay. But this is the technical term present in the book, so I'm using it. All right, so then in this step itself, we initialize the encoded string like we did earlier. Okay, how you start with the first byte or the first letter. Okay, first entry, or it can be byte, or it can be letter, because it depends on what is the problem. Okay, of input stream. Okay, so I initialize. So normally this will be the first step. I don't have to do anything in this. I have to go to the next byte or next letter, next entry, right? So that will be the second step. All right, so read the next entry. Okay, or even a byte, that works fine for us. Entry of the input. Right, so now I'm going into a loop, right? I'll come back to step number 2 again later. Okay, so I move to the step number 3 now. Right, it's something like, what if, right, let's say there are only 2 strings, right? I have to finish that, right? If there are only 3 steps, it's finished. Otherwise, now if I see that something like I got a b and next once again say b, so I started with this, right? I concatenated with this, then I concatenate with the next one. Okay, so if the concatenation concatenating the byte to the encoded string produces a string that is present in the dictionary already. Let me assume that I have another string that is coming here. Say this is simply okay, AAB maybe. So A is done. Once again, I read the next one. There is a right, which is already present. Okay. So if you get a string that already exists in the dictionary, right? Concatenate that to the encoded string, right? Now you see this is the difference. We didn't had this step earlier. Okay, so if concatenating the entry or the byte uh, to the encoded string. Encoded string in the sense it's output. Okay, whatever partial output we got, we are referring to that. All right. That string say produces a string that already exists in dictionary, right? This implies you have to do simply concatenate the byte to the encoded string, right? So you add the whatever string you got, right, to the encoded string. Encoded string already it is there. Add it at the end. So you do the concatenation. Okay, so concatenate the byte to the string. Okay, in the sense this is okay. I'll make it more clear. String refers to the encoded part. So let me make it clear by writing encoded string. Okay, so that's the step number 3. In the step number 4, if the concatenated whatever letter or a byte to the encoded string produces a string which is not in the dictionary. Okay, so if the concatenated byte to encoded string produces a new string. New string, that means it is not in the dictionary. Then we do the following steps, right? So what I do, add the new string to the dictionary, right? This implies you have to do this step, add the new string to the dictionary. This is the first step. Write the code for the encoded string as an output. So that part, right, whatever code we write, that becomes an output string. In the sense, that's the encoded string. All right. Okay. So this will be the next step inside this step number 4. So we have to write the code for encoded string to the output string. Okay, once that is done, it has another subpart. So set this encoded string equal to the new byte. So in the sense, whatever is encoded, that becomes my next byte, okay, or the next letter. All right. So we have to set the encoded string as new byte or new data, right? Then go to step number 2. Okay, so that means I read my next entry. So every time you read, you check whether it is this case or it is this case. One of them. Either you do go to step 3 or go to step, right after step 2. Right? Once it is done, so that will be the step number 5. So if I'll write end of the string, okay, you can write in your own words. It's EOS stands for end of the string. Right? In the sense incoming stream is over, right? That means write the whole coded part as your output. Okay, if the end of string, write the encoded string to output data. All right, so that's how you perform the encoding. Right, so here itself I'll give even the decoding part, right, so that, that later on we can directly go to the problem, right? So this is the decoding. Here also we will write step by step. Okay, so now again you have to initialize the dictionary over here. Normally the dictionary part, initial part of the dictionary will be given to you irrespective of the whether the question is encoding or decoding. For both we need the initial dictionary. Okay, that will be given. Initialization part will be done in the question. Okay, so again it becomes, it's necessary to initialize the dictionary containing one entry per, it can be byte, it can be digit, it can be letter, etc. Right? You can have your data stream as letters, numbers, or computer-based representations will use called as a byte. Okay, no problem. So that's the step number 1. In the step number 2, read the first code from the incoming stream. But you see the incoming stream is nothing but it is the encoded signal. Now we are receiving the encoded data. I want to do the decoding, but it still is an input for us. Okay, so read the first code word from the input stream and write the byte it encodes. So I'll explain the meaning of this when we solve the problem, but it's something like by just looking at I have initialized the dictionary, okay, and after initializing the dictionary I get a new entry. Okay, this new entry will be referred to something, right, which is already existing. So then you write what is it decoding. That's what is the meaning of this. You are doing a decoding. Write the byte that it encodes, means you are trying to decode that. Okay, whatever it has been encoded, you are trying to write that, means what you are decoding. Okay, so initial phase will be very straightforward in this, in the decoding, because you simply look at the dictionary which contains the value of, right, maybe something like 1 corresponds to A, 2 corresponds to B, something like that will be there. You just write it as it is. That's why the step number this step is straightforward. Okay, simply do the decoding. That's what they say, right? So after that, step number 3, initial step will be like this only always. Okay, then it becomes slightly tricky in next steps. Okay, so slightly different than our LZL. Okay, in step number 3, so I have to read my next read the next code or code word from the input stream. Okay, that's fine for us. Let's go ahead. Yeah. Okay, this is step number, I'll move to step number 4 and write. So if uh, okay, so write out the string encoded in this code word. I just have to concatenate. Once again, we do the concatenation here. Concatenate the first character. Right? Again, this can be a bit, this can be byte, this can be anything. Okay, a number or a character. Okay, letter, etc. So that's why we write a character in the new code word. To the string produced by the previous code. Whatever code which was there previously. Okay, so previous code word refers to that, and add the resulting string to the dictionary. Okay, now after this, I will go back to the step 3. Go to step 3. If not end of the string or a string, right? Once it is done, you come out and write the encode, decoded data to the output. So step number 6, write the encode, not encode, sorry, this is decoded, right? Because we are doing the decoding. Write the decoded data to the output. Okay, now, okay, so let's go to a problem to understand what we are supposed to do. All right. Okay, so perform LZW encoding for the following data. Okay, the data is A, B, A, B, A, B, C, A, B, A, B, A. Okay, right. So always right, initial dictionary will be given. All right. Initial dictionary will be given. Something like, okay, you use 1 for A, 2 for B, and in the third position you store C. Okay, it's actually, even if they don't give, doesn't matter, we can definitely write this. Okay, right? Again, you see, it's not like 1 2 3 has to be written. All right, you can start with 0 1 2, no problem, absolutely fine. Okay, maybe you, when you refer your class notes or something, you may see that okay, they are starting from 0, absolutely fine. Okay, no issues. Okay, right, like this is the initial dictionary given. Okay, sometimes they give because if they don't give, students write different possibilities. Like somebody might start from 1, 2, 3. Somebody else may start with 0, 1, 2. So they have two different answers to tackle, right? So that's why what they do, they normally give the initial dictionary. In the sense, everybody has to follow the same. That's all. Okay, fine. For that reason, they will give the this thing, initial dictionary, right? That's why it is expected. Okay, so let me assume that this is non-browse now. So we'll start with the dictionary itself, right? So what I call it as an index, right? That's 1, 2, 3, and the data. Okay, so data means it is given. So I'll start with that. This is 1 for okay. Let me write a capital letter. It's fine even if they don't give. Because the data given stream is in capital, so we'll write that. Okay, so there's A, B, C. So 1 for A, 2 for B, 3 for C. This is given. All right. So now the encoded data I'll write here. So initially it's not there because it's not the data, right? Data comes in the next step. So see, 4 is my actual data. That is, I read the first letter. Okay, I'll slightly up so that you can see that. Okay, so you see what I'm doing, I'm reading my first character, right? First character is A, right? But A exists already in the table, right? So you see, I told you one point earlier. This method will never encode a single character. Like A will not get an encoded output, correct? Do you remember I told earlier? So B will not be encoded as it is. C will not be encoded as it is. Okay, makes sense, right? So that's why we have written dash 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 for the encoded column of the first 3 entries of the dictionary, because those are the 3 different characters we see in the incoming data, right? So it is not encoded. So A already exists. I don't write A, I go to the next one. So that is AB, right? So A is not my value I'm going to consider as a data. AB is the data I'm going to consider. Okay. All right. So I look at the A part, what is existing already, that will be your output. Okay, that will be your output. Write the last character of your current data as your next data. Okay, that means my next grouping should be starting from B. Okay, so the same step has been explained, has been written in the steps. Maybe when I wrote the step you didn't understand, because obviously that's obvious. Okay, but now you understand. So it says that you overlap and you do the concatenation of the last one with the next data. That's what is the sentence present over there. Last one is the B, next coming is A. So do the concatenation and check whether that is there. Okay, BA is not there, right? So I'll write a BA here. This becomes index 5 for me, and I see B is present. You just check whether B is present. It's there. It will be 2. So my encoded data becomes 2. Okay, right. Let's check now the next one. I check. I have to start with overlapping with A, AB. AB exists, right? So proceed further. ABB. No. AB you don't stop, because already existing means it is already there is a code. Go to the next one, that is APP. Is it okay? So next I'll write the data is ABB. This is 6. Now I am not just checking for A, I'll check for AB, right? Its index is 4. So your output or the encoded data is 4 now. Right. Let's go back. Now ABB is over. Start with the last one. Okay. Only one will be overlapped. Okay. Not many. You don't have to start with BBA. Okay, so only the last one. Overlapping happens with the last one, last character of the string, current string. So BAB. Okay, BAB exists. BAB, let's check. BAB does not exist. So I'll check BA, right? BA is there. It is, right? It is 5. Okay. After the BAB, let's proceed further. After BAB, what do you have? BAB. So BC, right? B exists. So BC does not exist. I'll write a BC. Okay. So my next entry will be BC, right? This is 8, out of which I need to check for the, leave the C, just check whether you have B. Yes, I have B and the number is 2. Is it okay? All right, let's go ahead. So after BC, next is CA, correct? So CA exists? No. This is 9, out of which I check for C, that is 3, correct? Okay, after CA, let's proceed. After this CA, AB is there, so I'll include the next letter as well. So it is ABA. Okay, let us quickly check whether I have ABA. I don't think so, right? So the next entry will be ABA. So when I write ABA, this is going to be the index number 10, 10th position in the dictionary. So out of which I will check for AB, previous 2 characters. AB exists. AB is 4, right? So index becomes equal to 4. Okay, let's proceed further. After that, okay, which one? ABA is over. So AB, I'll check. AB is there. Yes, AB is there. ABB, I think we have. ABB is also there. Yes. So then I need to go to the 4 letters, 4 letters, ABBA. ABBA. This is 11, out of which ABB exists, right? So that is 6. Right, remember, people make one mistake. They stop here. They should not stop, because you have to consider the last letter as your new character, correct? So last letter will be there, that is A, but you don't have to write. Okay, because if I write once again something here, this has to be carried to the next iteration, right, or the next row. Don't do that. You don't have to do that. Just take that, what is the last letter, that is A, right? So check that, what is the number of A, what is the number corresponding to A? It is 1, right? So that 1 will be sent at the end. So you don't have anything to store in the next, no updation of your what you call dictionary. Dictionary does not get updated. Okay, so you understood, right, this step? Don't forget this. Always the last step has to be considered over. That ends the dictionary. Okay, so dictionary is not updated, right? But corresponding to this A, sorry, corresponding to this A, you have an output. That's all. Okay, right. So now if we want to write the encoded output, that will be only these numbers starting from here. Okay, this is your encoded stream. That's the output. All right, so we'll write that one. What is it? 1, 2, 4, 5. 1, 2, 4, 5, 2, 3, 4, 6, 1. Okay, so that's what you are trying to say as an output of this technique. Okay, now, right, let's go to the decoding technique. Okay, so in the decoding, all right, let's write in this way. Okay, again, the initial, see, this will be given once again. Okay, so this you have. Okay, if the question is only to do the decoding, still also you have, still you will be given this. Okay, so let's assume that. So perform the decoding of this is the question. Let's assume, right? Then also you'll be given, right, what is your dictionary, initial dictionary. So you start with that. Let me write the, okay, index and the data. So index always 1 for A, 2, 3, 3 for C. This is given. All right. Now I'll start with the, okay, I'll add a, okay, this is how we write. So let me write the received data here, and let me write its corresponding decoded data here. Okay, so this is the table. Okay, and again you see initially nothing, because that's the initial dictionary here. All right, what do? You pick up what is received, first data, that's number one. Okay, so one corresponds to what you see here, right? So it's A. All right, now I don't have to write anything here. You're not updating the dictionary as it is, because one already exists, right? So what I do, I'll go to the next step. Sorry, that's, oh, sorry, the next data received, not number two. It's, in this case it is two, so I have to write that. Okay, so next to receive data, that is two. I will check whether it is existing. It will exist, so corresponding that you write P. Okay, so this is the updated. Now you see, right, next step onwards, in the sense, after, just leave the first step. Immediately after the second step, you go with the updating of your dictionary. So this dictionary keeps updating now onwards, in the sense, after the second step of the decoding. Okay, decoding begins here. This is the first step of decoding, that is over. Second step onwards, it gets updated. Okay, right. So that means you have to increase your index number is 4. The idea is that whatever is here in the previous step plus this, okay, that is AB. So your data in the dictionary becomes AB. Is it okay? Right? So it becomes more clear when I go to the next step. So look at what you receive next. What do you receive next? 4. So come down. Now you see you have 4 readily available. So 4, what is the data for? It is AB. So that is your decoded data. Right? Now I have to update. That is the fifth one. Right? What will be the fifth one? You see, this is the previous one and the first letter of this. Yeah, first letter of the most recent decoded data. Complete previous data plus the this one. Okay, so it's like BA. So this will be BA. All right, that's great. Just see what you receive next. Sorry, it's after 4, 5, right? Okay, so next one is 5. So 5 is BA. So it is the complete previous data plus first one. Okay, so that is 6. It is A, B, B. All right, only this is a step, right? That is important. What I am supposed to write in the data column, right, controls everything here, right? Don't miss. Complete previous data plus 1. It can be bit, it can be digit, it can be letter, whatever, right? Whatever you write here, it's one of them only, not the complete. Okay, complete previous one plus one of the most recent decoded data, that will come in the data. So that is ABB, right? After 5, let's go back. You receive a 2. Okay, so that is 2. 2 means what? Just go back and check what is 2. 2 is B. right? So what should be the seventh data that you are updating? BA, and there is only one, so it is BAB. Okay, that is done. Let's check after 2 3, right? So go back to 3, check 3. 3 is C. 3 is C. See this one. So I write is C, right? It's BC. Okay. Next, just let us check what we have after 3. We have 4. So 4, 4 is AB, right? So it is CA. CA, that's all. Okay. Complete previous and the current. Yes. So this is AB is over. Okay. This is 9. So CA. Then we have 6. Next to receive data is 6. Go back to 6 to check what is it. It's AB. So 10th one, ABA. All right. Then the last one, which is 1. So go back to 1. 1 means it is A. Okay. So since after this, yes, definitely I can fill this, but it is optional. Okay. Because there is no upcoming data, no data after this, right? So what I want, you see, I just want the second column as my answer. Okay, so just this second column, read row wise, and in the sense up the downwards, A B, right? Yeah. Okay, so that's what I want. So I don't have to fill this actually because it's the last one. But anyway, that's fine for us, right? So I can write A. That finishes the whole process. Okay, so if you compare this column, all right, with our given data, right, that's initial data, it matches. Okay, so that's how you do the encoding and decoding of the using the LZ. Pretty straightforward method. Okay, but when you study both, I have seen I got a feedback saying that okay, we get confused because both are pretty much right, close to each other. Okay, all right. Okay, just practice two, 3 problems in each case. Then there is no question of doubt. Okay. Uh, all right. Let's proceed. I will give you a question for you to solve now. Okay, in the class. Yeah. Okay, I'll show you the previous steps also so that you can follow and solve. So this is the data, right? Encode using LZW technique. So this is the data. Okay. Data is AB, C, A, B, A, A. Okay, with the initial dictionary as this one. Okay, so this is given index and the entry. Or in this question, they say it is entry. Otherwise, previously we wrote as data. Okay, it's one and same. So they are giving 0 for A, 1 for B, 2 for C. Yes, it's, this is the initial data. Okay, all right. I will show you the, this is, you wrote this, right? Completely? Okay, I'll go back to the steps, right? Okay, I'll write horizontally. Okay, so I'll write the answer. So that is encoded data will be, yeah. So 0 0 1 4 0. Yes. Okay. 2 0 3 5 7 7 1 0 14 and 17. Okay. Did you consider the last letter of 17? Huh. Okay. Just so you mean this is 16? The last one is 16? Okay. Okay. Let me write it as 16. Okay. Huh. Okay. So you see the last is ARA. No, no, no. Output will be coming for the next character. Okay. Output of the last character. No, 16 is there. 16 is written, correct? So I have a part. I'll just show you what I mean. So you see here ABB was ABBA is mine, correct? So A is, yeah, that's my question. Okay, so you have a 0 coming up, right? Okay, perfect. Yes, yeah, that's the point. Okay, ultimately, don't stop here. You have to make sure that you will write. Yes, in the sense, whatever 16 corresponds to, right? Whatever it is that corresponding to the last digit or a number or whatever it is, corresponding to that, you get one output. Okay. Okay. That is this 0. Okay. I think 0 is not visible to you. I'll write. Okay. So that is slightly makes this 0, 14, then 14, then 16, followed by a 0. Okay, so looks pretty much fine. This answer is what is expected, right? Now there is a homework part for you, right? You are supposed to perform the decoding part of this. All right. So decoding part of this will be the homework. Okay. So then look at your question paper, right? If there is anything that you find interesting, anything new which you are not able to solve, you let me know. Otherwise,